Now we're going to talk about how to go from standard to scientific. So first, I'm going to give you an example that's not on the paper that you have, just our own example to work with. So we have 93 million. First of all, you ask yourself, is this a big number or a tiny little decimal? It's a big number. How we know it's big is it's more than one. If it's one or bigger, it's big. If it's less than one, it's tiny. So this one's a big number. That means that when we do times 10 in our scientific notation, that this is going to be a positive exponent. We want to move our decimal so that the number is more than 1, but less than 10. Hopefully that phrase is really familiar to you. More than 1, or it could equal 1, but less than 10. So we want to write 9.3 because that uses the same digits, but it makes the number more than 1, but less than 10. Now we have to count how many spaces we went to go from the end of the number to between 9 and 3. So we count our spaces, not our zeros, but our spaces. 1, 2, 3, 4, 5, 6, 7. I should say not just our zeros, but our total number of spaces. We went 7 spaces, so I write a 7 there. Let's do another one. 563,000. So again, I first assess, is this going to be a positive or a negative exponent? Since it's a big number, it's going to be a positive exponent. So we put times 10, and this number here is going to be positive. Then we decide where the decimal is going to go. We want to make this number more than 1, but less than 10. It could equal 1, but more than or equal to 1, but less than 10. So I know it's going to go between the 5 and the 6. So we're going to get 5.63. So now we have a number that's smaller than 10. 5.63 is smaller than 10, but more than 1. And we count our spaces that go from here to between the 5 and the 6, where we've put our decimal. That means our decimal has moved 1, 2, 3, 4, 5 spaces. Remember that we're counting spaces, not just the zeros, but the spaces. Okay, let's try one more. I almost gave you the exact example. 5,437,000. Big number, that means when we do times 10, this is going to be a positive exponent here. I know it's going to go between the 5 and the 4 to make it 5.437. Then we count our spaces. I went past 3 zeros and then the 7, the 3, and the 4. So that means I went 6 numbers, 6 spaces. And there's my answer. Once you get it, it's really not that complicated of a system to do. Okay, now what I'd like you to do is to do example A. So you're going to pause your video and try A. If you didn't have the paper with you, let me show you what it looks like. In example A, we have 2,340,000. And I'd like you to pause the video and write that in scientific notation, then check your answer. You tried it. I want you to try it. Get an answer. A wrong answer is way better than no answer at all. So first, I know it's a big number because it's more than 1. So it's going to be a positive exponent. I also know that the decimal has to go between the 2 and the 3.4. So it's 2.34. That makes this number more than 1, could equal 1, but less than 10. And I count my spaces. When I look at this, I'll give you the answer. I got 6 spaces because they went from there to there, and that's 6 spaces. Okay, so there's that one. Now let's talk about the smaller ones in the next video.